Hello YouTube, what I got here is a blue LED and a red LED in parallel, and then I just have fuel line connecting them. So that's why you see that green spectrum in the middle. And this is going into the negative terminal of this graphene supercapacitor, which is 35 volts, 10,000 UF. And as you can see, there is a diode there, so it's going to the right, and this wire is going back to here, which is just touching the ground on the concrete. And this is the iron core here. My phone is wigging out, not working proper. And I also just bridged these LEDs, so essentially I turned this back on with these LEDs even though I was bypassing it with these diodes by creating another relative ground touching here to here, and that created a forward voltage that keeps these on now. And so I decided to make a light bar with just empty fuel line, and then they're NP junctions, right? So basically I'm just putting them together and making them help each other. And then I wondered what it'd do with the water if I put water in here and did it with the red. And then this is just like a light bulb with a glass jar right here because it's really bright. But yeah, what we have here on the aluminum foil is basically it's connected to this output side of here. And so this line to the base of the transistor is going to the positive of this little capacitor bank, which is going up here, as you can see, to this LED, which then it goes through a resistor and a diode to the central rod of that one, which then goes into another little capacitor bank into the battery bank. So it might be hard to do with one hand, but I'll put this underneath the rubber band here, and then I'm going to touch this here on the outside. That's just the metal heat sink of this transistor. Alright, so as you can see, the wire is now attached to this aluminum foil, and this aluminum foil, if I touch it directly to the center rod, it'll collapse this scalar wave here, which we can see. And then those ones remain lit, right? But then if I touch here, so this switch is off, even though it's connected to the source battery with the polarity. And then let's turn up the brightness here. And then I'll touch this. You can see the sparks and the motor start to move. So let's get it to stop oscillating, and then we'll touch it again. Kind of interesting. So I'll give it a spin and then touch it. Just breaks up on me. And you can see it's still running. You might have heard me touching different things. So what I was touching is in between the negative of this capacitor bank and this aluminum foil. So yeah, kind of interesting. Still running there. Let's turn this off. And then what if I touch from here? So basically it's positive like the AD node here, because I just touched right here. which is going over to right here, as you can see on the outside. So as you can see, it's already connected through that. But then when you directly connect it, right, to the shell of this guy here, so I just touched the shell of this microinverter, and this red LED stayed on, but this blue LED turned off here. All I did was I literally just touched the outside of that. So I spray just a little bit of water on the concrete here, and as you can see, the red LED is a lot brighter now. And I'll just touch this here, and sure enough, as you can see, I'm just touching the water on the concrete here. Oop. I can even touch with both sides, I think. Doesn't do as good with both sides until it's a good bridge between the LED to make a nonlinear junction. But yeah, it's just so I guess touching this surged so much energy through the increase of capacitance suddenly from my body that it burned out the blue LED but did not burn out the red one. So I was taking off this LED, and what's interesting is I guess it's not burnt out because I just touch it and it lights back up. But what's weird is, unlike before, when it's touching this side of the diode making contact, it's not lighting up like before. So kind of weird. Then I touch it with my hand and it works fine. So I got the same LED, but it's on its own wire now, and that's going up to here. And then this wire is looped around this a few times and then goes out this way. And then I decided to keep this separate for the red, and it seemed like this little screw here on the microinverter body was a good place to tap from. And then it's also got a diode coming in, and as you can see, they're both lit there. And then I took a little spare capacitor I had and threw the negative on this side of the diode of the red, and then the positive on this side of the diode on the blue. So yeah, just some interesting stuff and effects today. LEDs for the most part are still lit, but I was messing around and I touched my ground pipe back here, which is connected to my solar ground and everything, which is obviously connected to this charge battery ground. And when I touch that directly to this side right here of this LED here, it turned this off, and now basically it doesn't spark from here to here like it did before, like I was showing, nor does it turn it like it does. And then yeah, I'm getting like very little light when I touch this, whereas before I got a lot more. So yeah, just some interesting stuff. You can still see it's switching and it's on, but depending on what you touch, you can kind of create different relative grounds and turn things off. So yeah, it's kind of hard to show here, but when I measure across the LED and I'm measuring for voltage, we see no problem here. It's going off the meter at that chart, but it doesn't change the LED brightness. So we'll go to 10 on the meter. Oops. So we're measuring around a few volts. Perfect for a green LED, right? Kind of cool. And then let's measure the current. So I'll go to 250 milliamps to negative, measuring the current, and we see the light go off and the dial go up. And then when I take it off, the light comes back. See that? So you can see a real current coming out of this, and we have the diode on the cathode side going that way on this ground terminal, right? And this ground is going into this water cell. And then essentially we see this red LED is off now that I've touched this node to my ground pipe over there, which is connected to my ground on this side, right? And when we measure the current across this, as expected, we don't see anything. Oh, gotta touch it. Kind of hard to do. But yeah, you don't see anything. And then when I go to the voltage one, we're on the 10-volt mark, as you can see. And then I go across this. And you can see voltage when I can touch it. Okay, so I guess we're measuring, yeah, like 3.8 volts or so across that LED without it lighting up. No current, but so yeah, that's coming into this cell, and these are wired together, which is wired to this aluminum. And interestingly, as you can see from the center to the aluminum of this one, you can see this LED still lighting up. So I have another LED as an indicator here, and as you can see when I touch it, it turns on. And then if I touch it here, we have scalar collapse just like before, and then they reset. And then when I touch it to this terminal, this is the positive side of the LED going into the one that's not lit, going into the negative terminal. So it lights there, as you can see. On the other side, it does not light. So we still have current flowing here, so maybe the LED is burnt out, huh? So I guess the final test would be, so I have a replacement LED at the same junction, and as you can see when I press it there, it lights up. So basically by touching from here to that ground over there, it burnt up that LED. Alright, so I replaced that red LED just like before with one connection coming in here and then one connection going directly to here on the outside of this cell. And as you know, this positive lead right here goes to right into here, which is essentially the anode side of this diode, which is going to this AD node down here. So yeah, it lights back up again. So as you can see, there's a slight differential of voltage from these different diodes. 9:05 p.m. and here's the microinverter LED status. I have this little power supply thing here. We got 250 volt capacitors here that are 100 UF, and on this side is 35 volt. And so yeah, you can see the red is just touching the microinverter body. You know, it's not hot, it's not going to hurt me. Like, I can touch all this, right? And then the negative lead, as you can see, is connected there. Kind of interesting effect. When I touch this guy here, that LED turns on, as you can see. And then it kind of dims over time if I don't keep it touched. And then what I can do is switch from here to here. See that? And then let's make like a little bit of a spark gap. So I got this wire here that I can kind of like act like a little spark gap here. So yeah, these are both connected to this ground side of this graphene supercapacitor right here. As you can see going in, it's not connected to the positive. And then this is connected to the screw right there. And then this one is connected to that. And that is this wire, which goes all the way down here. And if you follow this guy here, it's this guy here, which is going in, the one covered in black tape, to this AD terminal node. And yeah, just wanted to show this effect because if you understand this is a NP junction, and these are burnt out right now because it's too much energy for these LEDs. So the idea is you could maybe take MOSFETs like type N and type P, and then there's a differential between the two, and we can switch them. The faster you have this one touch from here to here, the more energy you're going to have shocking across before it dissipates there into radiant energy and whatnot. So you want it fast switching, and you need to, like, you can't just have a switch like this where basically you would try to just press the button, because then this polarity follows the switch, and like, I can press it and short it and switch it like that, but if I try to use the switch essentially with this guy, it's not behaving the same, because it's not the same as like pulling this off and touching this, because this is getting polarized in a different way on these leads. But anyways, so this isn't connect to anything, as you can see, and I replaced this big 35 volt 560 UF capacitor with a 25 volt 100 UF capacitor, and then essentially if I connect this to positive, nothing that way, and then positive on the blue side, see that green LED light up, we got real energy there. And then positive to negative on this side of the diode versus this side, see that? Oh, so negative on this side and positive on this side. That makes a big snap. So yeah, this is the output side, and obviously we're charging these capacitors here on this side, and then these pins don't see any voltage or anything like that. And then we got this fan running off of this 144 watt inverter, and the odd thing is that with this fan going, my meter sees 9 watts less of electricity at the meter versus when it's not going. So that's kind of interesting. By powering this load of this fan right here off of this inverter, my house sees less power at the meter. Right now, we're pulling 18 watts of electricity using 2 fridges powering our Wi-Fi and all other lights and devices off. So I showed you earlier this guy sparking, but what if we connect to over here? See that red flash every time I touch it? Maybe not. So every time I touch over here, you can see the red flash and then it fade, right? So that's the positive here. So that was this ground wire, which is negative, which is positive on this capacitor, to this side over here. And when it's on this side, right, it's like shorting this capacitor. And then as you can see, smoky volcano capacitor here, as you can see. So this is pretty hot here. I'll just take this off. So the idea is I have a longer wire on my positive side right here. And so my positive side is tied into the positive of this, which is like connected to this node here. And the negative side is connected to this graphene double wall supercapacitor, and it's rated for 35 volts. These are only rated for 16 volts. But I had this one here, so I thought it could handle it, but clearly it cannot. But yeah, I just wanted to show that effect. Basically, if I have a longer wire on the positive side, and this will be pulsing AC negative, like over 60 volts or 50 volts or so. And so this will be AC positive, and then the DC will be around like 25 volts here across this LED. The LED is burnt out. It doesn't light up anymore, but the junction is still there and it still acts as a directional NP junction. But regardless, if I had the negative here, same as where it's at really, and then I have this positive wire going to here, the spark is a little bit bigger when I discharge it versus when I don't have this wire and I just tap it on there. So we can get a new capacitor and show that. Oh, also right now I have this LED in pulsing configuration. Just that way it's like an indicator for this setup. And I did that by basically moving the wire that is currently right here, which goes to the positive of this cat bank, which is in parallel to this, which is running off of this. As you can see, we got the water cell here, and it's kind of cool. We're growing a big crystal in here. So you can kind of see it's a blue and black spiral going down. Kind of amazing. So we got blue, black, and white crystal, and then we got it in the pulsing configuration by taking this wire from here and moving it to that point on the battery bank, whereas before it was right here being fed in through this directional electrolytic capacitor, so that it was kind of forcing it in. So yeah, no, this thing keeps growing a lot of like different crystals, and they're like, as you can see, just growing and falling down and whatnot. And then so this is lead. This is just like a lead sheet. But yeah, here's an update on this other cell, which looks much darker now. There you can see sacrificial anode down in there. And having a hard time getting it to focus on that part down in there. But you can see it's formed like a cool little string in there. So the filings on the right of iron are still floating, and it's forming this weird little thing on here, which is kind of cool. And this LED is a red one, and as you can see, it's kind of glowing, but it's like burnt out. And then I made these LEDs brighter by basically taking this tunnel diode and sending it to the wire that goes in parallel on the input. But these resistors started heating up when I was basically sending some of that AC energy into this cap bank, and I burned those up that way. And then I burned this one up by trying to rectify some of the energy going across this NP junction with the capacitor, and it bounced back and discharged and like fried this. So if I just have a red LED sitting here, you can see that the cell is still active, the energy is still there, it's just not really being indicated. So these are fried, but they still act as directional diodes. So kind of handy. Alright, so I got a fresh new capacitor here. Alright, to compare wire lengths, we'll just do a quick negative positive tap, and then compare. So we got a little spark from that, tap, a little bigger spark that time because it got stuck on there. And alright, that was decent. So now let's connect this positive onto here, onto this wires, so we're effectively making this positively longer every time we do it. Alrighty, so we just tap, then we're gonna discharge onto here. That was pretty good. Just a tap and discharge. That one wasn't very big. Just a tap. That one seemed decently big. So it seems like it has more of a snap consistently when you have a longer wire on a positive side. Just an interesting observation with the bifield Brown effect. Kind of seems to apply with wire lengths and capacitors. Just a thought to consider. Oh, you like that blood blister from pinching wires as they shock? Here's a little grounding screw from my microinverter. So I'll run this to the ground pin of my potentiometer off my Bendini motor, which is right here. And as soon as I touch that, look at that. So yeah, that's off, but the wires are connected to the source battery. So it still has the dipole to fall through, even though the switch is off. And that's creating a lot of ozone, so I'm going to stop.